Rainwater collecting flooring saves water, gets rid of slippery floors quicker, and is a space-efficient solution. Specialized tiles will be installed into the ground and will connect to reserve tanks through water channels. But how will these tiles look like? Let's look at what we need. A relatively hollow interior and tensile strength to compensate for its lack of density. Why don't we take a look at the human bone? PNAS published a study done by Jens Bauer and a group of other scientists. Structures that were similar to that of the framework found in bones were put under the stress of uniaxial compression to determine their strength. We will focus on design type E as it has the highest compression strength. An important thing to highlight is that type E has the lowest air percentage. However, we will prioritize its quality of strength over its hollowness. Openings near the base will allow water to flow freely to the water channels. A hold layer on the top will be added to evenly distribute the weight.
The other method for collecting rainwater is collecting it from the roof. For flat roof, we'll create a pool at the roof and it will be transferred to a water tank if the rainwater is too much. For non-flat roof and towers, we'll make a pit on the edge of the roof to collect the rainwater. Also, we'll be using waterproof spray, which is inspired by lotus leaf, to not let the rainwater infiltrate and maximize the rainwater. We'll be using the rainwater for entertaining and cooling. We'll build a water spray pavilion as shown in this video. The pavilion will spray out water fog to cool down the tourists when they walk by. However, the rainwater is slightly acidic, which is not ideal for skin contact. The solution is to use spray hoses with pH-sensitive polymer. According to PNAS, the polymer will filter out hydrogen ion depending on pH value, and the rainwater can be used.
Another improvement we can do are installing electric pressure pads. Now on average there are around 20,000 visitors in Disneyland every day, adding to a grand total of around 7 million each year. The Hong Kong Disneyland has a main entrance with a line of ticket machines for visitors to go through, and human movements are concentrated in that small area. Taking advantage of the situation, we can install electric pressure pads along the pedestrian road on the way to the ticket machines. The mechanism is simple. It captures kinetic energy from movements on the pads and transforms it into electric energy. The electric energy generated could then be stored or used to power the ticket machines and even the streetlights along the main entrance. Not only that, the pressure pads could also function as a data collector. Gathering data like the amount of visitors would greatly assist in the functioning of the park that day.
Now, we will talk about how to make lining up less boring. We noticed that in Disneyland, the area for lining up in most of the games are usually long and they lack entertainment. Visitors may get bored easily if there's a long queue for the game. The use of the empty walls on two sides of the queue weren't maximized. Therefore, I think multiple screens can be added to the walls, and movies introducing the game can be played for visitors to watch, allowing them to understand the background of the game and to reduce boredom while waiting. However, it is not ideal if visitors can't watch the whole movie when waiting, since they may not be watching it from the start. To deal with this problem, sensors placed on the ceiling will track the visitors and play the video according to the position they're in. To simplify, as visitors proceed, the video will move with them, such that visitors no longer have to stop and watch the movie, and they can now watch the whole video whenever they start to line up.
In conclusion, these are the improvements we can make in Disneyland Resort. Energy and water could be saved and visitors' experience could be enhanced. Thanks for watching our video.